Before data can be retrieved from a vector database, it has to be ingested and indexed. So let us review the key steps that are involved in vector database knowledge ingestion and retrieval flow. The first step is to gather data that has to be ingested. Vector databases support both batch ingestion of files and documents that are stored in a storage system or a database, and real-time ingestion of streaming data. After data has been gathered, the next step is to optionally pre-process it. This can include steps such as OCR of scanned documents, redaction of sensitive data, any format changes, or extraction of metadata from documents, etc. After cleaning and pre-processing the data, the next step is to split it into smaller chunks. Chunking is a very important step in ingestion flow, and there are many techniques for splitting the data. We will learn about these chunking strategies later in a different presentation. But the key concept here is to understand that chunks make it easier for embedding models to capture semantic meaning in the vector embeddings. Each chunk typically represents one or few coherent ideas. This is different than a document that can have many topics. Having fewer ideas to embed makes it easier for embedding models, as they now have to capture less meaning in the vectors and therefore are able to do so more accurately. Better embedding quality leads to better retrieval quality. The retrieved results can now be focused and relevant to the search query and also smaller in size. Remember, shorter input prompts to the large language models lead to improved performance, improved accuracy, and reduced cost of the application. After we have created our chunks, we can optionally tag them with metadata, such as documents author, create date, topics, etc. Metadata is not embedded in vectors, it is stored separately as plain text. Therefore, it allows filtering the chunks during retrieval process for precise results. Once we have the chunks, the next step is to create vector embeddings of these chunks using a special model called embedding model. Remember, the embeddings capture semantic meaning of the data as numeric vectors. And finally, once we have the vector embeddings, we can store and index them in vector database. So this was the end-to-end flow of knowledge ingestion into a vector database. For data that is updated frequently, the ingestion can be an ongoing activity. Vector databases support both insertion of new vectors and also update of existing vectors. Now let us look at the retrieval process, which begins when the user sends the query to generative AI application. The first step in the process is to embed the query using the same embedding model that was used to embed the chunks. This is required for a semantic comparison of query with the embedded chunks within the vector database. Many vector databases automatically do this embedding when you send the query text, so this doesn't necessarily need to be an explicit step in your process. But it's important to understand that query needs to be embedded using the same embedding model. Once we have the query embedding, it is used to search the relevant context from within the vector database, which returns the k most similar results where k is configurable. Search results are then augmented to the input prompt for additional context that is sent to the large language model. The large language model uses this context to create a response that is grounded in organization's proprietary data, and the response is sent to the end user. So this was the end-to-end flow for both ingestion of information in a vector database and retrieval of information from a vector database. As a developer, besides choosing the vector database amongst many options available, the other important decisions you will make are which pre-processing steps to include, which chunking strategy to choose, and which embedding model to choose. Each of these decisions will have a direct impact on the accuracy and relevance of data that is returned to the end user.